Hi, and welcome back to Elementary Algebra. I'm your instructor, Amy Fuchsteiner, and we are doing word problems today with rational expressions. That means word problems that include a fraction component, specifically variables in denominators. So as this is a word problem section, if you haven't grabbed a snack yet, you might want to go ahead and do so. I'll try and remember to stop in the middle here to give ourselves a stretch. We might be in for a bit of a long one. All right, so there are four types of word problems that we're going to take a look at. The first are called number problems. The second is a shared work problems. They're my favorite. The third are uniform motion problems. And the fourth are investment problems. Investments are problems involving I is equal to PRT. All right, so let's get started with the first type of problem. That's a number problem, meaning we're only giving descriptions in terms of numbers. We're not actually doing an application, but rather we're attempting to find some number or numeric value. The first problem says, if a number is added to the numerator of 7/8 and the same number is subtracted from the denominator, the resulting answer or number is a negative 5/2. We're going to find the missing number. So if a number is added to the numerator of 7/8 and the same number is subtracted from the denominator. So I'm going to look at this fraction, which is 7/8. 7/8 has a numerator and a denominator. The numerator is the top number. The denominator is the bottom number. I'm going to add some unknown value to the numerator. Since I'm adding an unknown value, I'm going to rewrite this as 7 plus n, and all of that will stay in the numerator. That same unknown number is subtracted from the denominator. The denominator here is 8. That means we're going to be doing 8 minus n. Once I have done that, the resulting number is a negative 5/2. Right? So the equation that I'm looking at is 7 plus n over 8 minus n is equal to a negative 5/2. I have two fractions set equal to each other. I want to go through all of the same steps of solving that we did in the last section, 7.6. So I'm going to be sure to take note of the restrictions. The restrictions here are that my 8 minus n cannot be 0. This means that negative n cannot be negative 8, and n cannot be 8. So if I get an answer of n is equal to 8, that means I simply cannot use it. Because if I do, that's going to blow up this denominator. It's going to put a 0 in the denominator, and that's going to blow up the equation, right? Now, I also know that 2 cannot be 0, because my other denominator cannot be 0. But that's sort of nonsensical, as 2 isn't 0. So it's unnecessary to state. I also need to then find my least common denominator. The least common denominator uses the first denominator, which is 8 minus 2, or 8 minus n, and multiplies that by any additional denominators that haven't been included. That's a 2. So my common denominator is 8 minus n times 2. I need to multiply both sides. I'm going to rewrite this. So I have 7 plus n over 8 minus n equal to a negative 5/2. I'm going to multiply both the left side and the right side of this equation by that common denominator, 2 times 8 minus n, 2 times 8 minus n. On the left side, the 8 minus n's will cancel, and I'll be left with 2 times 7 plus n. On the right side, it's actually going to be the 2's that cancel, leaving me with negative 5, 8 minus n. Simplifying the left side, we have 14 plus 2n. Simplifying the right side, negative 40 plus 5n. To solve this equation, I'm going to subtract 2n from both sides. So I have 14 is equal to a negative 40 plus 3n. And I'm going to add 40 to both sides. This is going to give me 54 is equal to 3n, which I then just need to divide by 3. 54 divided by 3 is 18, and that should be my value of n. I can check this by putting 18 in for n, so 7 plus 18 over 8 minus 18 is 25 over a negative 10, which is a negative 5/2. There we go. Second problem. The reciprocals of two consecutive numbers is 7 over 24. Find the even integers used. So the sum of the reciprocals of two consecutive even numbers is 7 over 24. So the first one, we're just going to call n. Now, the consecutive number would be n plus 1. But since it's an even number, I have to jump up by 2. So the next one is going to be n plus 2. I don't need these numbers. I need their reciprocals. The reciprocal of n is 1 over n. And the reciprocal of n plus 2 will be 1 over n plus 2. The sum of those reciprocals is equal to 7 over 24. So now I have written my equation. It includes the rational expressions. So just like last time, I'm going to find restrictions. I know that n cannot be 0, and I know that n plus 2 cannot be 0. So n will not be a negative 2. And I need to look for the lowest common denominator, which will use n from the first term, the n plus 2 from the second term, and the 24 from the third term. I need to use all of these as there's no overlap between them. So I'm now going to take the left side and the right side and multiply each of them by 24n times n plus 2. And on this side, 24n times n plus 2. Okay. Moving carefully. The first term, the n's will cancel, leaving me 20, excuse me, 24n plus 2. The second term, it's the n plus 2 that will cancel, 24n. On the left side, it's the 24s that will cancel, 7n, n plus 2. Simplifying, this is 24n plus 48 plus another 24n. And this will be a 7n squared plus 14n. I can combine my 24n's, so I get 48n plus 48 is equal to a 7n squared plus 14n. Now, I'm going to subtract and move everything over. So I'm going to subtract the 48n. All right, 48n. This leaves me with 48 is 7n squared minus 34n. Subtracting the 48 over, I get 0 is 7n squared minus 34n minus 48. The first thing I notice is that this should be factorable. The factors would be 7 times a negative 48. I'm going to come over here now. 7 times a negative 48. I need my calculator to do this. On 7 times negative 48 is a negative 336. And if I look at a negative 336, see, I needed to add to a negative 34. Okay, that's going to be a negative 336 times 1. A negative 168 times 2. A negative 112 times 3. a negative 84 times 4. 336 will not be divisible by 5. I'm going to divide it by 6. So a negative 56 times 6. I'm getting close. The difference here is 50, and I need the difference to be 34. So now I'm going to do 336 divided by 8, and I get a 42. So it's a negative 42 and 8. So now I at least know the pair. This pair adds to 36, negative 36. Okay. So I'm going to do a 7n squared minus 42n plus 8n minus 48. I'm going to pull out a 7n, n minus 6. I'm going to pull out an 8, and I have an n minus 6. So I will have 0 is equal to n minus 6 times a 7n plus 8. Using the zero product property, either n minus 6 is equal to 0 and n is equal to 6, or 7n plus 8 is equal to 0, 7n is a negative 8, n is a negative 8/7. So I do have two solutions, which is on par with this being squared. So I have an n minus 6 and an n is equal to a negative 8/7. The important piece here is that I need two consecutive even integers. Find the even integers. I have an n is equal to 6 and n is equal to a negative 8/7. Only the n is equal to 6 is an integer, let alone even. So this is my even integer. If my n is equal to 6, then my next even integer is n plus 2, which is 8. So my two solutions are 6 and 8. This negative 8/7, while a solution, it is not valid for this problem. It would be extraneous, unnecessary, because it's not an integer. It's not even. So, all right, so there's a couple of number problems. Our next problem is the shared work problem. Shared work problems are my favorite. Shared work basically says that the work done is equal to the rate of the work times the time you have to do it. In this case, we are going to take the rate of one employee and the work done. So the time it takes us to do the work is going to be the work done divided by the rate. Okay. So the caterer can prepare the cream puff. Caterer can prepare cream puffs for an event in 4 hours. Her employee takes 7 hours to complete the same number of cream puffs. If they work together, how long will it take? So the time of the employer, the time of the boss, plus the time of the employee has to equal the time it takes together. That's how I do these problems. Now, the time of the boss is one job gets done in 4 hours. So the work done is one job. The rate is 4 hours. Plus the time of the employee is one job done in 7 hours. The time together is one job done, but we don't know how many hours. So this gives us our fractional equation, our rational equation, and we can look at our restrictions. We only know that x cannot be 0, which of course it can't, because It can't take them no time. They're not Sabrina, the teenage witch, right? They can't just snap their fingers and have it done. So x cannot be 0. And our least common denominator would be the 4 and the 7 and the x. So I'm going to multiply the left side and the right side by 4 times 7 times x. And then when I distribute this, for the first term, the 4's will cancel. And we'll have 7 times x plus. For the second one, it'll be the 7's that cancel. 4 times x equals. On the right-hand side, it will be the x that cancel, and that's just going to be 28. So this gives us 11x is equal to 28, and x would be 28 divided by 11, which is 2.54 repeating, 545454. So how do we write this answer? Well, it depends. These are always in hours because our time was in hours, 4 hours, 7 hours. So this would be about 2.55 hours or 2 hours. And then to get the minutes, we recognize that we had 2 full hours and we take those off. We don't need those anymore, but we need to take our 545454 and multiply it by the number of minutes that are in an hour. So I'm going to multiply this by 60 to get 33 whole minutes. So it's about 2.55 hours or 2 hours and 33 minutes. All right. Let's try the next one, which is about a reservoir. Reservoir? It's late. I can't say reservoir. Reservoir? Reservoir. Okay. Let's say we have a reservoir. It's being filled using 2 streams. The water department has determined that one stream can fill it at a rate of 1. It will take 15 days to fill. If it's only the second stream, then it takes 21 days to fill, a little bit longer. However, if both streams are stopped and we're just using the water, it goes empty in 24 days. Once the pool is empty, how many days will it take to fill the reservoir completely again? So, again, we need the time of stream 1. We're going to add that to the time of stream 2. And then we're going to add that, but not really, because the third one is emptying it. We're going to subtract the time to use up. And in the end, what we want is 1 full reservoir in how many days? Okay. All right. So stream 1 would be 1 stream fills in 15 days. The second stream fills in 21 days. But if those are gone, then we're able to empty that 1 reservoir in 24 days. If all of these are working in tandem, we will have 1 full reservoir in how many days? Okay. The best way I know to do this, because I've got a 15, a 21, a 24, and an x, is to use my factors again. I should note that the restriction is that x cannot be 0 because I can't have a 0 on the denominator. Doesn't matter for any of the rest of these because 15 is not 0, 21 is not 0, 24 is not 0. But let's factor the 15. That's 3 times 5. If we factor the 21, that's 3 times 7. And if we factor the 24, that's 3 times 8. This is helpful because now when I do the least common denominator, I know I need both things here. That's the 3 times 5. When I look at the second one, I see that I've already used the 3, but I could do the 7. And when I look at the third denominator, again, I've already used the 3, but I can use the 8. And when I look at the fourth denominator, I do need the x. So my lowest common denominator is 3 times 5 times 7 times 8. I'm not going to write in what that number is. I'm rather going to leave it as 3 times 5 times 7 times 8. Why? Because I need to multiply both sides by that 3 times 5 by 7 by 8 by x, and the 3 by 5 by 7 by 8 by x. And when I leave them all listed, it's going to make it easier to cancel with the denominators that are there. For example, when I multiply this, all of these by the first one, I already know 15 is 3 times 5. So I know it's the 3 and the 5 that'll cancel, and I'll be left with 7 by 8 by x. When I multiply all of this by the middle one, I can see I've already got the 3 and the 7. So it's the 5 by 8 by x that I need. And when I multiply this by the third term, I can see I've already got the 3 and the 8. So this is going to be minus a 5 by 7 by x. On the right-hand side, I need all of them, 3 by 5 by 7 by 8, but I don't need the x. The x is what's going to cancel. Whoops, 7 times 8. Now that I've got all this written out, I can do 7 by 8. That's 56. I can do 5 by 8. That's 40. I can do 5 by 7. That's 35x. Now I'll take my calculator and do 3 times 5. 7 times 8, and I get 840. All right, 56 plus 40 is 96. 96 minus the 35 there is going to give me 61. So 61x is 840. Now if I take 840 and divide it by 61, I get that my x is equal to 13.77 days. So when I re-ask the question, how many days will it take to completely fill the reservoir? I'm going to go with 14. 13 won't be enough. 14 will completely fill it, probably over. So I'm going to go with 14 days. All right, fantastic. Now we've got to do some uniform motion problems. The uniform motion problems use distance is equal to rate times time. So distance is going to be equal to rate times time. Let's take a look at this particular problem. Cyclists in the Tour de France can ride 50 miles in the same time that an average cyclist can ride 24 miles. Do you see these? Same time? That tells me that our times are going to be equal. So I'm going to need to use time is equal to distance over rate. Just dividing both sides by r here, and then I'll have to set those equal. If the average cyclist rate is 13 miles per hour slower than that of a Tour de France cyclist, how fast does the average cyclist ride? Okay, so the Tour de France is going to go 50 miles at some rate at some time. All right. The average person is going to go 24 miles, 13 miles per hour slower. So whatever rate it was minus 13 in the same amount of time. So I need to solve this for time. This guy, time is equal to 50 over r. This guy, time, is equal to 24 over r minus 13. My restrictions are 13 miles per hour slower. Yep. My restrictions are R cannot be 0. R minus 13 cannot be 0. So if I get 13, something is wrong. My LCD would be the R from the first denominator and R minus 13 from the second. So on the left side, I'm going to multiply by R minus 13. On the right side, I'm going to multiply by R times R minus 13. Okay, so on the left side, it's going to give me a 50, R minus 13. And on the right side, it's the R minus 13 that cancels, and I'll have 24R. Distributing, 50R minus 650 is equal to 24R. I'm going to subtract 50R from both sides. This gives me a negative 650 is a negative 26R. I don't know what that is. So I'm going to take negative 650 and divide that by negative 26. And I get 25 is the R. So, let's see, I divided by negative 26, divide by negative 26. Okay. I know that the rate is 25 miles per hour, but that's of the Tour de France guy. That means that the average person is R minus 13 or 12 miles per hour. Great. Let's try the next one. The next one is about a boat that travels 18 miles per hour in still water, and it can travel 22 miles downstream in the same time that it can travel 14 miles upstream. Find the speed of the current in the river. All right, so the current is traveling at R miles per hour. That's unknown to us. Downstream is 18 miles per hour plus the current, and it goes 22 miles. So we know from up above and from the last problem that we're going to use time is equal to the distance over the rate. Now, that means the time upstream is going to be the same as the time downstream. The time upstream is going to be the distance over the rate. So 14 upstream, the rate is 18 minus R. Downstream, they can travel 22 miles in that same amount of time, but the rate is 18 plus R. Because the time traveling upstream and downstream are the same, the distances will vary because you're going faster versus slower. If you've ever had to row a boat upstream and then downstream, you understand. It's not going to be the same. Our restrictions are that 18, I did not want to write that. Restrictions, there we go. 18 minus R cannot be 0, so negative R cannot be 18. Negative 18, R cannot be 18. Okay, 18 will 0 out. And 18 plus R cannot be 0, so R cannot be a negative 18. Well, that makes sense anyway, because the speed of the river can't be a negative current. You can't have the stream traveling in the opposite direction. It just doesn't work that way. All right, but let's take a look at our lowest common denominator. That would be the 18 minus R, which is our first denominator, and the 18 plus R, because these are not the same, so I need to include both. I'm going to multiply the left side and the right side by 18 minus R, 18 plus R. All right, on the left side, it's the 18 minus R's that cancel, leaving us with a 14, 18 plus R. On the right side, it's the 18 plus r's that cancel, giving us a 22 18 minus r. Distributing 14 times 18 is 252 minus 14r. 22 times 18 is 396 minus 22r. I'm going to add 22r to both sides. That's going to get me a 252 plus 8r is equal to 396. I'm going to subtract the 252 to get 8r is, 396 minus 252, 144. Now I'm going to divide that by 8. Rewriting that to get that r is equal to 18. So I think that the speed of the current is 18 miles per hour. What was I supposed to find? The speed of the current is r is 18, so 18 miles per hour. That's the speed of the current. Okay, great. One more, and it's all about the money, honey. We're going to solve some investment problems. We're going to talk about how much the money is worth. We're going to be using I is equal to principal times rate times time. But for this, t is always going to equal 1. So that tells us that our interest will be the principal times the rate. For most of these problems, the p is equal. So we are going to be using p is equal to the interest over the rate for most of these problems. All right, let me show you what I mean. At one bank, the sum of money invested for 1 year will earn $24 interest. If that same amount of money is invested in bonds, the money earns $72 interest. The bank interest rate is $4 less than the interest rate of the bonds. We're going to find the interest paid by the bank investment and by the bonds. So we know that the bank principal has to be the interest from the bank over the bank rate. In this case, the bank's interest is $24. The bank's rate is not known. I'm just going to call it R. We know that the bond principal has to equal the bond interest divided by the bond's rate. The bond's interest we know to be 72. The bond rate, the bank's interest rate is 4% less than the interest rate on the bonds. So that means that the bonds is 4% more than the bank. So this would be R plus 4. Now, what we can assume based on what's stated in the problem is that these two principals are the same. Since the principal amounts are the same, we can use the equation 24 over R, that's what we have for the bank's principal, is equal to the bond's principal, which is 72 over R plus 4. This allows us to set up a rational equation, the restrictions for which are R cannot be 0 and R cannot be a negative 4. Because if R is 0, that will blow up this problem. And if R is negative 4, that puts a 0 in this denominator and blows up the equation from this side. Our least common denominator is R times R plus 4. And I'm going to use that and multiply both sides by R times R plus 4. On the left side, the R's will cancel. On the right side, the r plus 4s will cancel. Distributing, I get 24r plus 96 is equal to 72r. Subtracting 24r from both sides, I get 96 is equal to 48r. Then dividing both sides by 48, we get that 2 is the rate. So 2% is the rate for the bank. R was the rate for the bank. For the bonds, the rate is R plus 4. So the bank is at 2%. The bonds are at 2 plus 4, or 6%. And that makes sense, because when you triple your interest rate, you should triple your money, right? 72 is 3 times 24. So that one will work. Okay, let's try the last one here. We have 2 bond funds paying interest rates that differ by 2%, meaning one is 2% more and one is 2% less. Money in Fund A for 1 year earns $315, while money in Fund B for 1 year earns $385. Find the lower interest rate. Okay. So if this one's $315 and this one's $385, the lower amount of money is going to be the lower interest rate. So if this is R, then this one has to be 2 higher, or R plus 2. Okay. So principal A is going to be the interest A over the rate for A. In this case, the interest A is $315. The rate A, I'm just going to call R. Principal B is going to be interest B over rate B. Now, the interest made on this guy is $385. The interest rate should differ by 2 from this previous one. And the more interest indicates it would be R plus 2, not R minus 2. We're assuming that the principals are the same. So that means that $315 over R has to be equal to $385 over R plus 2. Since that's how you divide that out to find the principal, and you divide this out to find this principal, and they're supposed to be the same. So that means I can set these guys up. My restrictions then are that R cannot be 0, and because a -2 would zero this one out, R cannot be -2. My least common denominator would be R times the R plus 2. All right, multiplying both sides by that common denominator, I notice that the r's will cancel, so this will be a 315 r plus 2 on the left side, and on the right side, it's the r plus 2's that will cancel, so 385 r. Distributing the 315 r plus 630 is equal to 385 r. Subtracting the 315r from both sides, to isolate that, we get 630 is 70r. Dividing both sides by 70, we get that 9 is equal to r. So the interest rate for principal A should be the 9%. That makes principal B R plus 2, or 11%. All right, so rate A should be 9%. Rate B is R plus 2, which is 11%. The lower interest rate is 9%. All righty. that should be it for the 4 examples of rational expressions using word problems. We have done some number problems. We've done some shared work problems. We've taken a look at uniform motion and at investment. If you have any follow-up questions, please don't hesitate to reach out to me or to contact the math center, I say math department, or the math center. Julia has a whole team of people just waiting to hear from you. All right. Thank you so much, and we'll see you next time.